Hello everyone. In continuation with the previous video, that is finding the cubes of a number. Again, I have put up the cubes from 1 to 15 and I'm hoping that with the next few videos, by the time we come to find cube rules, you should be learning these cubes by heart. Okay. Now, the first thing that we're going to do is there will be some numbers given to us and we have to check whether the particular given number is a perfect cube or not. We don't have any set rule using which we can directly predict whether it is a cube or not. The only method that we can use to check whether a number is a perfect cube or not is prime factorization. We cannot decide looking at the units digit and say that it is a cube. It's not possible. In perfect squares, we had those rules, and it was applicable, and it was more easier to predict using looking at the units digit number at the units digit. But for perfect cubes, whether a number is or not, we have to do prime factorization method. Okay, so we are going to proceed with the prime factorization method for each question to check whether it is a cube or not. So what is the rule for cube? If we are going to find the factors, each factor should be multiplied to itself how many times? 3 times. Okay, so let's check. So 216, right? So let's start. So 216. 2s are 1, 0, 8, 2, 5, 4, 2. 2s are 27, 3, 9, 3, 3, 3, 1. So are we getting here factor 2 which is multiplied 3 times and factor 3 multiplied to itself 3 times. So are we getting here 2 multiplied by 2 multiplied by 2 and 3 multiplied by 3 multiplied by 3. So indirectly if I make a pair, 2 with 3 is 6, 2 with 3 is 6 and 2 with 3 is 6. So I'm getting a 6 cube. So it is a perfect cube, right? Understood? Let's take the next one, which is 128. So again, the last digit is 8, so I'll go with the table 2. 1 will not go. 12 means 6, 4, 2, 3, 2, 2, 1, 6, 8s are, 4s are, let's go down a little bit, and 1. So let's make the groups of 3s. Because it's cube, so groups of 3. So here I have this one extra 2 left, means I'm having 2 multiplied by 2 multiplied by 2 and then 2 multiplied by 2 multiplied by 2 and then a 2. Means I have one pair of triplets, the other pair of triplets, but this is one which is left out. So it's not a perfect square. Here it's yes and this is a not because I have one extra 2. Correct? Let's take to the next one. 864. Right? Okay, let's do 864. 2s are 4, 3, 2. Again 2s are 2, 1, 6. 2s are 108. Again 2, 54, 2, 27, 3, 9. So 3, 3, 3 and 1. If you look at this, we are getting a triplet of 3s. We're getting a triplets of 2, but then one more triplet of 2 is not possible here. Can you see that? Why? Because I have only two 2s. There's one extra 2 which is missing. So is it a cube? No, it's not a cube. So we say it's a no. Okay, we'll say a no. Right? Let's take the next one. Okay, let's do one thing. Let's write down the roots here, so it's more easy. Okay, so let's start with 46656. 2s are 2, 3, 3, 2, 8. ones are 6, 6, 4, 2, 5, 8, 3, 2, again 2, 2, 9, 1, 6, 2, 1, 4, 5, 8, again 2, it's going to be a long one, 14, so 7, 2, 9, 3s are, you should, 729 is actually 9 cube, okay. 2s are, 4s are, 3s are, 2, 8, oh, sorry, brave mistake, 81, so 3s are, oh, sorry, it'll give me a 27, 9, 3, 1. So how many 3s I have? 1, 2, 3, 1. So I have a triplet of 3 and I have one more triplet of 3. So this is satisfied, right? So let's talk about the 2s. How many triplets of 2s I have? One triplet of 2 is here visible and one more triplet of 2 is visible. Correct? So I have 2 pairs of triplets of 2 and 3 triplets of 3. So can I write it like here? I write it here. So I have 1, 2, 3, 4, 5, 6. So I'm having the first triplet of 2, the second triplet of 2, then I have the first triplet of 3 and the second triplet of 3. Nothing extra is added on. So we have perfect cube here. So yes, it is a perfect cube. Okay. Am I clear? Sure? Okay. So let's start. The next extra problems, let me explain to you if you have a very, because all these numbers which I've taken is more of an odd number. So even numbers if they have, like suppose 243. So it goes with the table of 3. Okay. This you should remember, it's 11 cube. Okay. So go ahead and say it is a perfect cube. But for others, you need to check. Okay. Now, this is a very, very easier one because 100 is, you know that it is 10 multiplied by 10. So is it a perfect cube or not? You can directly write it without even finding the factors by prime factorization. Okay, so these are the 6 questions which I have for extra practice. Now the next type of question. Find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. Similar to what we did in perfect squares, or right, remember, multiply the smallest to make it a perfect square. So what did we do? We found the factors by prime factorization and we multiplied the missing one, right? So same thing we are going to do here. So let's do the prime factorization on the right corner. So 2 zar is 36, 2 zar is 18, 2 zar is 9, 3, 3, 3, 1. So here what we need to do is we need to have a group of triplets, 3 number groups, right? So here we are getting 2 multiplied by 2 multiplied by 2 and then we have 3. So I have a triplet of 2's but I don't have a triplet of 3. How much less is it? Yes, 1 extra 3, 5 multiply becomes a cube root. So we'll say we will multiply 3 to 72 so that it becomes a perfect cube. Okay. So we'll say 72 multiplied by 3 which is going to be a 216 which is a 6 cube. Right? Clear? Let's take the next one, 256. So again, 2's are 1, 1, no, 2, sorry, 8. 2's are 64, 2's are 20, no, 32, sorry. Again, 2's are 16, 2's are 8, 2's are 4, 2's are 2. Let's go down a little bit more. 2 and 1. Let's make the groups. First triplet, second triplet, and 1 extra 2 is missing. So we'll say 2 multiplied by 2 multiplied by 2 and then 2 multiplied by 2 multiplied by 2 and then 2 and 2. So I have one triplet there, the second triplet there, and for this one extra 2 is missing. So we'll say we will multiply 2 to 256 so that it becomes a perfect cube, right? So which number we are multiplying by? 2. So 256 multiplied by 2 will give me a 215, which is a 8 cube. Okay, clear? Let's take the next two questions. 968. 8, so I'll start with 2, which is a 4, 8, 4, 2, which is a 2, 4, 2, 2, which is a 1, 2, 1, 11, 11, 11, 1. So clearly I have a triplet of 2, but I don't have a triplet of 11, right? So it will be 2 multiplied by 2 multiplied by 2, 11 multiplied by 11. So I have this triplet, but I don't have the triplet of 11. How many missing? One extra 11 has to be multiplied. So we will multiply 11 to 968 so that it will become a perfect cube. Okay, so that will give us 968 multiplied by 11 will give us 1331, which is a 11 cube. Okay, let's take the next one, 6125. Because the last digit is a 5, so I'll start with 5. 6125. So 5s are 1, 2, 2, 5. 1s are 11, so 2, yeah. 12. Again 5. So 2s are, 4s are, 5s are. Again 2. 4s are, 9s are. Oh, sorry, 5 times. Mistake. Sorry, 5. 5 4s are 20, 45. So 7s are 7, 7, 1. So again, I have a triplet of 5, but I don't have a triplet of 7. How much less? 1 7 is less. So 5, 5, 7, 7. So which number I'm going to multiply here? 1 7 has to be multiplied. So we will multiply 7 to 6125. That will make, that will, sorry, so that it will become sorry, a perfect cube. Okay, so we are going to multiply by 7, which will give me a 42875, which is a 35 cube. Okay, hope this is clear. So by prime factorization, you will find out which number is not as triplet and how much less. Accordingly, you will do the multiplication. Okay, hope this is clear. These are the extra questions that I have taken. Again, if you can see here, I have taken 100. So you, without even doing the prime factorization, you can say which number is less. Okay, the others you have to do the prime factorization and figure out which is the number less to make it a perfect cube. So that number you will multiply to make it a perfect cube. Okay, am I clear? It may be a pair of 2 also. Like here, if you see 900 is 9 multiplied by 10 multiplied by 10. So this is a perfect square. These are also perfect squares, right? So you can have 3 digits here. 1 3 is left, right? 5 and 2. You will get 3 factors which are less. So you are indirectly going to multiply by 30 to make it a perfect cube. Same way if you talk about this one, 64 multiplied by 100. Now 64 is a cube of 4. So 4 cube, that is perfect. But this is less by a number 10. So you will multiply 10 to make it a perfect cube. Am I clear? Okay. Thank you.